All right, we're going to be solving equations and checking our answers, in fact. So what I'm going to do is I'm going to do these odd problems right here. The goal of this thing is that, you would circle the letter down here that corresponds to the answer up here. I'm less interested in that helping you out right now, but what I'm going to do is number one, I'm going to write x plus 8 equals 21. And the first thing I want you to do is write this long line right here, because what we're doing is we're saying that there is the left side of this equation, there's the right side of this equation. And if you're wondering why that is, it's because we talked about mobiles. And a mobile was this thing that hung above your crib when you were a baby. There's the ceiling. I don't know why it's so wavy. And things hung from your mobile. And what happened is that if it was all balanced, then it would look like this. And if you're like, what do you mean like this? I mean like this, that this portion is completely straight across. But if we were to hang another mobile just down the way from yours, and it was imbalanced, then what's happening is that like these objects are bigger and heavier and whatever compared to, say, this little one, right? And you would look at this and you would say, oh yeah, these are definitely pulling this structure down. It's pulling things downwards. And this guy just doesn't have enough to pull down enough so that it could be all even like this. So that's what's happening right here, is that this left side is like this left side, and this right side is like this right side, okay? And what we're going to do is we are going to subtract 8 from this side, okay? So the idea is that imagine if we were to take this piece right here, okay? In fact, I'm gonna erase that and actually do that. I'm gonna take this piece, this blue piece, and if I were to then, hold up, here we go. If I were to drag it up here, then what would happen is that would change the balance of this thing, and it would become more like this one. Now, I'm not guaranteeing this is what's gonna happen. In fact, my tools here are not fancy enough to just make it happen, but the idea is if you do it to one side, ... you must do it to the other side. Why is that? Because of this guy. Because of the equal sign, okay? If you don't respect the equal sign, then things are not equal, okay? And then you guys know how unfair it is when things are not equal. Mom comes home from the store, here's the cookie I got for your little brother, and here's the cookie I got for you. It's half eaten and 8 times smaller. These are not equal, and you would be very upset over here, right? Okay, so back down here, if we subtract 8 from one side, we must subtract 8 from the other. And here's what's gonna happen. These guys didn't move, right? These blue lines didn't move. So this X right here, he does not move. In fact, he stays on this side, yes? And is there anything else on this side? No, because if I subtract that 8 from this side, he's now gone. And then when I do 21 minus 8, this is now 13. And notice that the X is over here all by himself. That must mean that this X is equal to 13. So number one might be 13, but let's do this. Let's double check ourselves. Let's plug in our answer to make sure. Is 13 plus 8, does that equal 21? Of course it does. So 21 equals 21. We are happy campers. Number 3, y minus 7 equals -4. We are going to establish the two different sides of the equation. I'm going to be adding 7 because I want to get this y by itself. And on the left side of the equation, there was that pesky minus 7 hanging out there. So we're going to add 7. And now this y is by itself. And negative 4 plus 7 is 3. Is that true? Well, if I have 3 and I subtract 7 from it, if I'm feeling positive 3 and I get 7 insults, I'm going to be feeling negative 4. Number 5, I'm going to draw this line because we have a left side and a right side. And here's z. It's being subtracted by 1.75. So I'm going to add 1.75. If you're a little confused by me writing this right here, let me get rid of it. I'm going to add 1.75 to both sides. These cancel out because negative 1.75 plus 1.75 is 0. This z is now just z. And now right here, we're just going to add. 2 plus 5 is 7. 8 plus 7 is 15. Keep the decimal. 1 plus 3 plus 1 is 5.57. So to check my answer, I'm going to take this and plug it in right up here. In fact, I'm just going to rewrite it. 5.57 minus 1.75. Does that equal 3.82? Well, how I have always subtracted and messed with decimals is I make them vertical. So I'm going to try this. 7 minus 5 is 2. I can't do 5 minus 7, so I'm going to borrow and do 15 minus 7 is 8. 4 minus 1 is 3. So look, I got 3.82 and 3.82. I did this right. Number 7, 8.7 plus b equals 14.5. We have the left side, we have the right side. 8.7 is adding to b. So I'm going to subtract 8.7 from both sides. Why am I subtracting 8.7? Because 8.7 minus 8.7 cancels. And this b just drops straight down. Okay? I have to borrow here 13. We get b equals 5.8. So I need to check to see if that's right. So 8.7 plus 5.8, does that equal 14.5? Well, again, I always line mine up. 7 and 8 is 15. 1 plus 8 is 9. 9 plus 5 is 14.5. So check it out. That is the same as that. So we are correct. Number 9. 3/5 plus c equals 1/4. The left and the right side here. By the way, you don't have to label left and right. I just am right now. So what's happening is that 3/5 is adding to c. We are going to subtract this 3/5 from both sides. So minus 3/5 minus 3/5. We have c is going to equal. Now we need a common denominator here. That's how you subtract fractions, right? And it looks like we're going to multiply this by 5 over 5. And this one by 4 over 4. Where am I getting those from? That 4 is that 4. This 5 is this 5. We have 5/20 minus 12/20. What does that end up being? That ends up being negative 7/20. Fun, right? Especially fun because we are going to plug this in right here and check our answer. So does 3/5 minus 7/20, does that equal 1/4? So I'm going to multiply this by 4 over 4 to get 12/20 minus 7/20. 12 minus 7 is 5/20. Does that equal 1/4? Yes, it does, because If we divide that by 5, divide that by 5, we simplify it. We get 1/4 equals 1/4. So we are happy to get negative 7/20. Don't forget that was our answer. Negative 7/20 was this guy. Last but not least, I say last but not least because I am going to be doing about half the problems these days, and I always want to save my word problems for people to actually give their best attempt on. So here we go. 5 3/4 equals D minus 2 1/8. 5 3/4 equals D minus 2 1/8. Okay. We have the left side, we have the right side. What's happening is D is being subtracted by 2 1/8. So we're going to add 2 1/8 to both sides. That goes away. This goes away. And we're left with this D all by itself now. Similar to the last one, we need a common denominator. I'm going to multiply this by 2/2 to get 5 6/8 plus 2 1/8, which is 7 7/8. That is what D equals. Now we need to check that. So we're going to take that and plug it in right there. Does 7 7/8 minus 2 1/8 equal 5 3/4? Let's find out. 7/8 minus 1/8 is 6/8. 7 minus 2 is 5. So are we looking good or are we not looking good? I think we're looking good because we can divide this by 2, divide that by 2 to get 5 3/4 equals 5 3/4. So we're good. That's our answer.